Good morning, my dear students of Standard 9. Welcome back to the chemistry class. Dear students, we are talking about chapter 6 from your chemistry book. Last class, we got the conception of mole. Today also, we will learn about this mole. Last class, we got the idea of mole, that is mole is a counting unit, like 1 dozen, 1 pair. In this way, mole is also a unit. Now, 1 mole of anything means 6.02 into 10 to the power 23 particles of this thing. Not only this, 1 mole is its molecular mass amount. 1 mole water is 18 gram water. 1 mole carbon dioxide is 44 gram carbon dioxide. That things we learned in our previous class. Today we will equalize 1 mole with volume, that is called molar volume. Molar volume, that is the volume of 1 mole of a gaseous component. You have to remember one thing, that molar volume, it is applicable only for gaseous component. And molar volume is volume of 1 mole of a component. So, the volume of 1 mole of a component is called its molar volume. And this molar volume, it is fixed for every gas at standard condition. That is, at standard condition means at standard temperature and pressure. Standard temperature, that is 0 degree Celsius temperature, and standard pressure, that is 1 atmospheric pressure. At standard temperature and pressure, 1 mole of any gas occupies 22.4 liter. That is the molar volume of gas. That means molar volume of any gas at standard condition is 22.4 liter. Look, this is 1 mole of gas. This may be nitrogen, or it can be carbon dioxide or oxygen or methane also. That means 1 mole of any gas, this gas occupies 22.4 liter. That means its volume is 22.4 liter because it is at standard condition. The volume occupied by 1 mole of a gas is called its molar volume. And standard temperature and pressure, that is 0 degree Celsius temperature and 1 atmospheric pressure. Now look, this is 1 mole hydrogen. This is 1 mole oxygen. This is 1 mole nitrogen. But all their volume is same because they are in standard condition, and at standard condition, at STP, standard temperature and pressure, their volume is 22.4 liter. It is written here decimeter cube. Decimeter cube is also liter. Decimeter cube or liter. So, at standard temperature and pressure, 1 mole of a gas occupies a volume of 22.4 liter, which is called its molar volume. Here, 1 mole helium, that means it is 4 gram helium, because we got this idea in our previous class. From the previous class, we can tell this 1 mole of anything is its molecular mass amount. 1 mole helium, it is 4 gram helium, and at 0 degree Celsius temperature and 1 atmospheric pressure, its volume is 22.4 liter. Dear students, look here, it is written 273 Kelvin. This conversion you will learn, but not now. That is 0 degree Celsius temperature means 273 Kelvin. 1 mole oxygen, it is 32 gram oxygen because the molecular mass of oxygen is 32, and its volume is also 22.4 liter. In the same way, nitrogen, that is 28 gram nitrogen, and its volume is also 22.4 liter. So, we can tell 1 mole of any gaseous component, that is 22.4 liter. Its mass is its molecular mass, it is helium, so it is 4 gram helium, and there are 6.02 into 10 to the power 23. It is helium atom. So there are 6.02 into 10 to the power 23 atoms helium. Now we will learn about some formulas. By using this, we can do the math. That is, all are related with mole. This N, it denotes mole. N equal mole number. N equal W divided by M, where W is mass in gram and M is molecular mass. N equal gram molecular mass. N equal W by M. N equal V by 22.4. V is volume of the gas in liter and this is 22.4 liter. N, mole number equal capital N divided by Na. This capital N, this is number of molecules, and Na, this is Avogadro's number. That comes 6.02 into 10 to the power 23. You can use this formula for doing math, or without using you can do also math. So here we will do the problems now. Molar volume of a gas calculations. At first, problem 1. For every math, I will show here in two ways. One is without using formula and another is for using formula. You can follow any of these two. How many molecules are there in 25 liter methane at STP? Look, here you have to calculate the number of molecules at 25 liter methane. So this number of molecules and the volume of methane both are related with mole. So we can write 1 mole methane equal 22.4 liter methane at STP equal how many molecules? 6.02 into 10 to the power 23 molecules methane. Now dear students, look, you have to calculate the number of molecules present in 25 liter methane. Here look, in 22.4 liter methane, how many molecules methane present? 6.02 into 10 to the power 23 molecules. So we can write in 22.4 liter methane, number of molecules present 6.02 into 10 to the power 23. So in 25 liter methane, how many? In 1 liter this, and in 25 liter methane, there are 6.71875 into 10 to the power 23 molecules methane are present in 5 liter methane. So answer comes 6.71875 into 10 to the power 23. Sorry, there will not be gram. It will be only 6.71875 into 10 to the power 23 molecules. You will make the correction here. It will not gram. It is molecules. Same math if we do by using formula. Look here, what is needed here? Here there are volume and also molecules. We learned there are three formula for mole, that are N equal W by M, N equal capital N divided by Avogadro number, N equal V by 22.4. Here there is given V equal 25 liter and N equal number of molecules. Here we will use two of these because we need the volume and molecules. So here we will write N equal V by 22.4 equal N by Avogadro number 6.02 into 10 to the power 23. Now from there we can write, we have to calculate how many molecules. That means we have to calculate this N. So from there we can write N equal V into 6.02 into 10 to the power 23 divided by 22.4. So now put the value of V, that is 25 liter, and the result comes same 6.71875 into 10 to the power 23. So 6.71875 into 10 to the power 23 molecules of methane are present in 25 liter methane at STP. This is our required answer. 6.71875 into 10 to the power 23 molecules. Now, second one, what is the volume of 4 mole oxygen gas at STP? 4 mole oxygen. Here we have to relate the mole and volume only. So we can write 1 mole oxygen equal 22.4 liter oxygen at STP. 1 mole oxygen equal 22.4 liter. So 4 mole oxygen equal, the volume of 1 mole oxygen is 22.4 liter. So the volume of 4 mole oxygen is 22.4 into 4, that comes 89.6 liter. So the volume is 89.6 liter. This math also you can do by using formula. Just see here. Here there is given only the mole n equal 4. So we can use here only one formula, that is n equal V by 22.4. Here n is given. You have to find out the value of V. V equal n into 22.4. That comes 89.6 liter. Okay. Now, third problem. What is the volume of 100 gram carbon dioxide gas at STP? Here also both we will relate with a mole. 1 mole equal 44 gram carbon dioxide equal 22.4 liter carbon dioxide at STP. So the volume of 44 gram carbon dioxide is 22.4 liter at STP. So the volume of 100 gram carbon dioxide is 50.909 liter at STP. So it comes 50.909 liter. This math also you can do by using formula. Here also there is given W equal 100 gram and molecular mass, this is 44 gram. You have to calculate the volume of it. Here also we will use two formula, that is n equal V by 22.4 equal W by M. So here everything is given. We have to find out the V only. So V equal W into 22.4 divided by M. And when you will put the values, then V come 50.909 liter. This is the answer. Now, what is the volume of 60 nitrogen molecules at STP? Here also both you will relate with mole, molecule and volume. 1 mole nitrogen equal 6.02 into 10 to the power 23 molecules nitrogen equal 22.4 liter nitrogen at STP. So here the volume of 6.02 into 10 to the power 23 molecules nitrogen equal 22.4 liter. So the volume of 60 nitrogen molecules equal, it comes 2.23 into 10 to the power minus 21 liter. And the answer is 2.23 into 10 to the power minus 21 liter. Here also the formula you can put here. There is given n equal 60. You have to find out V, and you know the Avogadro number Na. So we will put the formula n equal V by 22.4 equal n by 6.02 into 10 to the power 23. So V equal n into 22.4 divided by 6.02 into 10 to the power 23. And you will put the value of n, that is 60, and it comes 2.23 into 10 to the power minus 21 liter. It is the answer. Same math, all math are same type. Just you will see that what is given and what you have to calculate. The things, if it is volume or molecule or mass that is to be calculated, you will put it in the right side, or you can put the formula also. By any method you can do the math. Here you have to find out the mass of 500 liter of HCl gas at STP. Here you have to relate the mass and volume with mole. 1 mole HCl equal 36.5 gram HCl equal 22.4 liter HCl at STP. So the mass of 22.4 liter HCl is 36.5 gram, because you have to find out the mass of HCl, so you will keep it in the right side. The mass of 22.4 liter HCl is 36.5 gram at STP. So the mass of 500 liter HCl, it comes 814.732 gram. It is the answer, 814.732 gram. Here also you have to use two formula, that is N equal W divided by M equal V divided by 22.4, where everything you know, just you have to find out the value of W, the mass of HCl. So W equal M into V divided by 22.4. M is the molecular mass of HCl, 36.5, and V is V is 500 liter and 22.4 it is given. So the answer comes 814.732 gram. This is the last map. How many hydrogen atoms are there in 5 liter ammonia gas at STP? Dear students, in one ammonia molecule there is 1 nitrogen atom and 3 hydrogen atoms. So at first you have to find out the number of molecules present in 5 liter ammonia. Then you will find out the number of hydrogen atoms present in 5 liter ammonia. So here we will relate the mole with its volume and also the number of molecules. 1 mole ammonia equal 6.02 into 10 to the power 23 molecules ammonia equal 22.4 liter ammonia at STP. So there are in 22.4 liter ammonia there are 6.02 into 10 to the power 23 molecules. So in 5 liter ammonia how many molecules present? 1.34375 into 10 to the power 23 molecules of ammonia present in 5 liter ammonia. But look, you have to calculate the number of hydrogen atoms present here. So we know in 1 molecule ammonia there are 3 hydrogen atoms present. So in 1.34375 into 10 to the power 23 molecules ammonia, 3 into this, it comes 4.031 into 10 to the power 23 atoms hydrogen present in 5 liter ammonia. So the answer comes 4.031 into 10 to the power 23 atoms. Here also if you want to put the formula, then at first you will find out the value of N, that is the molecule number of ammonia, that is N equal V by 22.4 equal N divided by 6.02 into 10 to the power 23. Here V is 5 and you have to find out the value of N. So N equal V into 6.02 into 10 to the power 23 divided by 22.4. It comes 1.34375 into 10 to the power 23 molecules. This is the number of molecules of ammonia present in 5 liter. Now just same as previous math. Here in 1 molecule ammonia there are 3 atoms, so it comes 4.031 into 10 to the power 23 atoms hydrogen present in 5 liter ammonia. So dear students, today up to this math, now we will see the significance of the molecular formula, relation between mole and molecular formula. Dear students, suppose methane CH4, it is the molecular formula of 1 mole methane or 1 molecule methane? Already this question comes to you. You are confused that CH4 will tell what? It is 1 mole methane or 1 molecule methane. H2O, it is 1 mole water or 1 molecule water. The formula, it denotes what? 1 mole or 1 molecule. Now here I will make it clear. That is, I will relate this mole and molecule while writing its formula. Molecular formula provides some information, such as in case of methane. CH4, by seeing this formula, you can tell that it is methane. The formula of 1 molecule methane is CH4. That means CH4, this formula denotes molecule of methane. Not only this, the formula of 1 mole methane is also CH4. So, if I tell you to write the formula of 1 mole methane, you will write CH4. If I tell you to write the formula of 1 molecule methane, you will write this CH4. 1 molecule methane contains 1 carbon atom and 4 hydrogen atoms. You know this. 1 mole methane molecule also contains 1 mole carbon atom and 4 mole hydrogen atoms. In 1 mole methane molecule, the mass of carbon atom is 12 gram and the mass of hydrogen atom is 4 gram. So the total mass of 1 mole methane molecule is 16 gram. In 1 mole methane molecule, the number of carbon atom is 6.02 into 10 to the power 23 and the number of hydrogen atoms are 4 into 6.02 into 10 to the power 23. That is 2.41 into 10 to the power 24. But the number of methane molecules, it again 6.02 into 10 to the power 23 molecules. Dear students, this is the significance of molecular formula. By seeing the formula, these things you can easily tell. Okay, now I will give you some homework. This homework you can do by using any method. If you want, you can use formula. If you don't want, you can avoid the formula. You can do the math without using formula. So by using any method, you will do this homework. What is the volume of 250 chlorine molecules at STP? What is the volume of 4 gram SO2 gas at STP? How many oxygen atoms are there in 2 liter carbon dioxide gas at STP? What is the mass of 60 liter methane gas at STP? So dear students, today up to this, thank you everyone. See you in next class. Goodbye to all.